Hey everyone. Today we are going to look at equivalent expressions with distributive property. This was your get the goof for the day. The answer was 12x squared plus 6x. Florence forgot to multiply the x with the x to get 12x squared instead of just 12x. Okay, on with the lesson. Today you will learn to determine whether expressions are equivalent. For example, Quincy's expression is 4 plus 5p times 2p, and it says my expression 2p times 5p plus 4. If you notice, these expressions are equivalent because the commutative property of addition says that you are allowed to switch two terms around and it will still be the same thing. So commutative property of addition says you're allowed to switch these two terms if you'd like, and it still means the same thing. Okay, the first one we're going to do is a simple one. It says, is 30c equal to 2 times c times 15? Okay, so here's what you want to do. You want to make sure that you are applying your properties of addition correctly, properties of multiplication correctly, including the distributive property. So we need to remember the commutative property, the associative property, and the distributive property when doing this. Okay, so this first expression, 30c, you cannot do anything more with it. It's already simplified. So let's see if we can simplify this one. According to the properties of multiplication, the associative property says if this is all multiplication, these parentheses are not necessary. Therefore, you're allowed to remove them. So you're just going to have 2 times c times 15. And then when you combine everything together, because in multiplication you're allowed to combine everything together, 15 times 2 is 30. And this is going to make 30 times c. Now 30 times c, you can simplify that even more. You can just shove your coefficient with your variable and it still means the same thing, 30 times c. So therefore, these two expressions are equivalent because when you simplify them, they equal the same thing. Okay, that was example 1. Example 2, we have 8k times k squared plus k, and we want to find out if that is equal to 16 times k cubed. Okay, so if we start over here, 16k cubed, it cannot be simplified anymore. It is already simplified. This over here, if you remember the distributive property says you're allowed to distribute the 8k to both terms in this addition problem. So let's start off by doing that first. You want to distribute the 8k with the k squared. You do that through multiplication, so we have 8k times k squared. Okay, then what you want to do next is the operation inside the parentheses comes next, so plus. And then you want to distribute the 8k with the k, the second term. And that would make 8k times k. As you can see, the 8k has been distributed with k squared, and the 8k has been distributed with the k. Now on to simplify. In multiplications, we have two multiplication problems here. We are allowed to shove everything together. Okay, so 8 times the coefficient of 1. Remember, when there's no number here, it's a 1. 8 times 1 is 8. And then k times a k squared makes a k cubed, because the exponent for k would be 1 if you don't see it, and you simply, to multiply k to the first power with k to the second power, you basically just add the exponents together to make k cubed. Okay, the second term, 8k times k. I'm going to use a different color here. When you don't see a coefficient from the k, it's a 1. 8 times 1 is 8. K times k would be k squared. Okay, because the exponents would be 1 if you don't see it, and you simply add the two together to get the exponent for this k. Okay, what we have left is 8k cubed plus 8k squared. Now remember your rules of addition. You're only allowed to combine these two terms if they have the same ending, since we are adding. Okay, so this 8 has an ending of k cubed. This 8 has an ending of k squared. We are not allowed to combine the two because in order to add these, they both have to have the same ending, and these do not. The exponents must be equal along with the letter. So, is this expression equal to this one? No, because this is simplified right here. You cannot add them together, therefore it is not equal to that. So not equal for this one. Okay, for this next example, we have 10p squared to the second power. Is that equal to 5p times p plus p? Okay, so we want to make sure both expressions are simplified to see if they simplify down to the same thing. As you can see, 10p squared is already simplified. You can't do anything more with it. With 5p times p plus p, we can apply the distributive property to simplify this expression more. To do that, I can multiply 5p with p. So 5p times p. Then we're going to bring down the addition sign. It goes in the middle. And then last, we're going to distribute the 5p with the second term of p to make 5p times p. Okay, so we have 5p times p plus 5p times p. Next, in distributive property, we need to simplify the two terms that are being added. So if you remember correctly, this is multiplication. You're allowed to shove everything together in a multiplication problem. So 5p times p, the coefficient for p would just be 1. 5 times 1 is 5. P times p is p to the second power. And if you remember, if they don't have exponents, it's 1. And you simply add the exponent together to get what it multiplies p out to. Okay, and over here we have the same thing. 5p times p. There's a 1 in front of the p. 5 times 1 is 5. P times p would be p squared. Because when you don't see an exponent on the variable, it would be 1, and you simply add the exponents together to get the exponent for the simplified version. Okay, now we have to add these together, but remember the rules of combining like terms, adding, they have to have the same ending. Okay, this 5 has an ending of p squared, and so does this one. Therefore, these are like terms. We are allowed to add them since they have the same ending. So 5p squared plus another 5p squared would be 10p squared. The ending does not change because you're adding. So is 10p squared equal to 10p squared? Yes, these two expressions are equivalent. So this math problem is equal to this math problem. Why? Because of the distributive property. This next example wants to know if these two expressions are equal or equivalent. Now, this one is very easy. It looks complicated, but it's very easy because if you remember, these are zeros. And this is saying 0 times this term, and then 0 times this term. If you remember correctly, the zero property of multiplication, anytime you take a term and multiply it by 0, the answer is always what? 0. So this expression here simplifies to 0 because it doesn't matter if you know what the variables are or not. If you're multiplying anything by 0, the answer will always be 0. And the same over here. This would also be 0 because 0 times this term is still 0. So in this expression, these two problems are equivalent because of the zero property of multiplication. Okay, this is a word problem. It says Sue and Mitch each wrote an expression for the area of the figure. Okay, remember what area means? Area of a square or rectangle is length times width. Sue's expression is 7 times 8 plus 4x. Mitch's expression is 7 times 8 plus 7 times 4x. They want to know, do both expressions represent the same area of the figure? Okay, so if you look at this picture here, it's actually two rectangles just put together. To find the area of this rectangle here, you would just do length times width, which would be 8 times 7. Okay, and then for this rectangle, this side is 4x. This side would be 7 because it's parallel from this side right here. So to find the area of this one, it would be 4x times 7. Okay, and what would you do with these two areas, 4x times 7 and 8 times 7, to find the area of the whole thing? You would add the two areas together. So in our expression we came up with is 4x times 7 plus 8 times 7. We need to see who is correct, or if they're both correct, or if no one is correct. Okay, so if you noticed, this looks like the distributive property backwards. If you notice, the 7 has been distributed with the 4x and the 8. So he would go on the outside of parentheses. The plus sign in the middle of these two areas would be in the middle of the parentheses. Okay, the 7 was distributed with the 4x first, so 4x would go here. And then 7 was distributed with the 8 here, so 8 would go here. And if you notice, it's the same thing. 7 times 4x plus 7 times 8. Okay, so if you look at Sue's expression, his looks exactly like ours down here, except 4x and 8 are switched around. But if you remember your commutative property of addition, it doesn't matter. If you switch these around, you'll still have the same answer in addition. So Sue's expression is actually equal to ours, which is correct. And then for Mitch, if you noticed, it looks just like ours, except that some things are switched around. 7 times 8, we have 8 times 7 instead. And then he has 7 times 4x, we have 4x times 7 instead. But if you remember your property, your commutative property of multiplication, you're allowed to switch the two terms around in a multiplication problem on both sides. And then he's actually got the 7 times 8 switched around with the 7 times 4x, which is the same thing as what we have, because the commutative property of addition says you're allowed to switch around these two terms and it's still equal the same thing. So do both expressions represent the same area of the figure? Yes. Sue is correct, and so is Mitch. This is the before the distributive property was applied, and this is after the distributive property was applied. Okay, here's another example of a word problem. It says a furniture store received 6 shipments of furniture on Tuesday. Each truck had X number of tables and Y number of chairs. 2 employees wrote expressions to describe the pieces of the furniture delivered in all. So employee 1 says it's 6 times X plus 6 times Y. Employee 2 says it should be 6 times X times Y. Do both expressions describe the deliveries? Explain your thinking. Okay, so 6 shipments means 6 trucks. Basically just means 6 trucks. Okay, and each truck, they had X tables and Y chairs. So what it really means is that, okay, so there were 6 trucks, and each truck had an X number of tables and a Y number of chairs. So how many tables and chairs does each truck have altogether? You would simply add X plus Y. And this is going to represent the number of tables and chairs just in one truck. But they were not just one truck. There are 6 trucks. So you would have to take this, add them together, and then multiply it by 6. And it would look like this. Okay, so if I were to apply the distributive property, 6 times X would be 6X, plus 6 times Y would be 6Y. So employee 1 is correct. Okay, and if you look at employee 2, he's saying that you should multiply the 6 trucks with the chairs with the tables. That does not make any sense. Why would you multiply chairs with tables with trucks? That just doesn't make any sense at all. So employee number 1 is correct.